Welcome to this instalment of the Build Test Solutions webinar series. Today we are joined by Professor Richard Fitton from the University of Salford and Andrew Parkin from Elmhurst Energy, alongside our very own Dr. Richard Jack. Today our speakers are exploring how much of an impact using measured U values rather than assumed values could make not just to EPCs, but the overall health and wealth of both buildings and occupants.
Thank you everyone for coming to the webinar. As Tanya said, our three speakers today are going to be myself, Professor Richard Fitton and Andy Parkin from Elmhurst Energy. And what we're going to talk about is, I'll try and set the scene, talk about why we're interested in this, why we're interested in it now, and what it is that we're talking about. Rich Fitton's going to take over and talk about a specific example of a project where he's used U-value measurements and what impact that had to try and give us a bit of the flavour of what the research says and to understand a bit more tangibly what we're talking about here. Then Andy's going to take over and talk about the practicalities for measuring U values and what it'll look like in practice, the protections we're going to put in around it with the scheme. And I'll finish off with just describing the change that we're talking about in detail. So what, why, and why now? Well, U values are foundational. So any sort of energy modelling that we're talking about, whether that be SAP, RD SAP, in the future HEM and RD HEM, or other models such as dynamic models or 12831 heat loss calculations for heat pump sizing, they're all built upon that input of what is the performance of each element, what's the U value of each element. So any imperfections, any inaccuracy in that foundational part of the assessment will percolate through and translate directly into inaccuracy in the outputs. And the outputs are important. So one of the key outputs is the Energy Performance Certificate, which is a document which underpins pretty much all building energy performance policy in the UK and in Europe, and will remain a key document for many years to come. And that underpins things like the Warm Homes Plan, our general targets towards net zero, and trying to deliver people healthy homes to live in, healthy warm homes to live in. So the U value is in some ways an abstract and metric and might seem unimportant, but actually it underpins all these models, which directly translates into billions of pounds of retrofit and new build spending and funding, and people's health. So we think it's really important. What is it and why now? So what we're suggesting is a small change to the conventions for RDSAP and for SBEM about being able to use a U-value measurement as an input to an RDSAP or an SBEM calculation. It's going to use mature technologies to calibrate EPCs. So this isn't a conversation or a debate about measurement or modelling, whether we should use the EPC. It's actually bringing the two together, using measurements to calibrate EPCs to make the documents as good as they can be. And it's a really similar process to the recent adoption of air tightness measurement as a permissible input to EPCs. So we're following that same journey. And why now? Well, to be honest, I've always thought this was a good idea, but it's timely at the moment with the recent publication of the Warm Homes Plan, current consultation on the EPC and HEM's part in that. So it's a timely time to think about whether we should adopt, whether we should try and improve the accuracy of these documents, given how important they are. What is the problem with using assumed U values and business as usual? So first of all, what is business as usual? Well, you can either use a lookup table that says, based on the construction type and the approximate age, we think the U value is about this. And those values generally are an attempt to represent the average performance of a particular construction type and age. Or we could do a U value calculation. So if we know the materials that are in a construction, we can think about the elemental performance of each, add them together and calculate the U value. One thing about this is that it means that we're assuming that a particular construction type has a U value. Okay, so let's now question whether those things are true, to think about whether it's worth doing to use U value measurements. So are the lookup tables right on average? So here we have a number of studies where people have gone out and done U-value measurements, and the figures in white there are the sample sizes. So one thing to notice is that sample sizes of in situ U-value measurements aren't that high, and that will be one of the big benefits of allowing this as a permissible input, is that we'd suddenly gain a lot more information about how buildings really perform, and it should help us to inform feedback loops to improve performance over time. And you can see here that if that little cross, which is the RD SAP assumption, matches the bar, which is the average measured performance, then the lookup table will be accurately representing the average performance of the construction type. So are they right? Sort of, I'd say. Sometimes they're right, sometimes they're not right on average. And in general, where there's inaccuracies, it seems that the actual performance of those constructions is better than the prediction, the assumption. But actually, the story's a little bit more complicated than that. So we're not just interested in the average performance. What about the spread of performance? So do all buildings of a particular construction type, do all constructions of a particular type perform the same? Well, here's the real rub. No. So if we look at this, these measurements, these are for relatively new builds. This was a study in 2020, and look at the distribution of measured U values. We can see we actually have quite a wide and flat distribution. And what that says is that the U values measured are different to each other. There's a lot of variety. So you can't just assume that all of these U values would have had the same predicted or calculated value, but actually in real life they vary a lot. And so that means that a single number does not accurately represent the performance of all the buildings of that type. So it's not good enough to be good on average. Here we can see the 95% prediction interval. So the amount of uncertainty in the prediction of the next U value is well over the average performance. So we can have a massive range in the actual performance. Let's look at that for a few different construction types, so those few different studies, and you can see that there is really big uncertainty, big variety in the U value of the same construction type. So the crucial assumption we make when we use a calculation or a lookup table is that one number can represent all these different buildings. Now we look at this uncertainty and see, actually, no, that is a really dud assumption. So are these assumptions, these averages, right for every building, these calculations right for every building? And I'm afraid, no, they're not. So we've seen that there's significant inaccuracy in those U values. Is it a big deal? Is it something we should do something about? Well, yeah, it is a big deal. Those uncertainties in the inputs of the U values of just one construction type make a difference of up to 10 SAT points. So we're talking about a variety of big shifts within a band or whole bands of movement due to the uncertainty in the U value of particular construction types. That has a direct knock-on effect that we're mistargeting where retrofits can be applied. We're not getting appropriate quality assurance on whether a retrofit has done what we think it should do. We're going to have unintended consequences if we design a wall or a floor or whatever to be a particular U value and it's a different U value. It will have a different surface temperature. We could run into issues with damp and mold. Has a direct impact on heating system sizing. So we're talking about heat pump sizing, how many radiators need to be replaced. And one really, really big thing that it would do to make this simple change is we'd incentivize best practice. So if you do a really good job of retrofitting a building and you measure it and prove that it works in practice, you can have that accurately represented in your EPC. So incentivizing the right thing. So we're talking about a measurement that costs in the low hundreds of pounds. On an individual building level, it's affecting spend in the multiple thousands of pounds. And it's really affecting the health of the people inside. Living in cold, damp houses is one of the worst things for people's health. So we think it's a big deal. We think it's worth doing. We think it's a really good investment to use those measurements. So hopefully that set the scene, what we're doing and why we're doing it. And now I'd like to pass on to Professor Richard Fitton to tell us what the research says and give us a bit more information about a particular case study.
So just take the National Trust out of your mind in terms of big old country halls. These are houses that they own, cottages and small farm holdings and things like this. Next slide, Rich. So the aim was very much to do what Richard was talking about then, is to take some of the assumptions out of SAP and RDSAP and measure against them. I think we had the same issues, that some may be good, some may be bad, some may be indifferent. But the point is there's a wide variance, as Richard just shown. So we did some in situ tests through the winter and the heating period, and hopefully the findings will align with what Richard said, which and a lot of other people have said, and just add some more depth to what they found as well. So and the idea was just to look at how inserting values into SAP and RDSAP made a difference. Next. So we looked at building types across the North and Midlands regions of England. They were all pre-1919 traditional solid wall. So that, to me, is some of the areas of concern. It's like the older building stock and the heritage building stock that have got quite a wide distribution of things that are happening in the wall. We looked at 3 semis, 6 detached stone houses as well. And just to kind of elaborate slightly, stone is a really kind of diverse thing, because the wall thicknesses, the rubble fill inside, they're all incredibly, well, as we're going to see in a minute, are quite different. There were some big houses, small houses, but they averaged out to be a typical UK home, just slightly above. Next. So I think I'm not going to spend long on this because Richard's covered some of this, but it's not just me who's doing this, not just Richard doing this and others, that this has been done for a long, long time. And, you know, we're standing on the shoulders of giants here, and there's some really, really good people doing this. Caroline Ryan and Scott and Sean Duran down up at BRE, should I say, as well, have been doing this for like decades. This was really just to emphasize some of the heritage stock. And the work they've done has updated the U values in SAP and RDSAP previously. We changed the U value. It used to be 2.1. We changed it down to 1.7. And we think that figure is far nearer the truth, but it just goes to show that we shouldn't assume things, and we should update our knowledge, and that will lead to change in the energy models. Next. So, like Richard said, U-value measurement, when done right, we're not in bandit country. Okay, there is an international standard. It's actually an American standard as well, which is fairly good. That's been developed for years and is updated and maintained on how we measure U values in non-transparent elements, in walls and ceilings, basically. We followed that methodology, and it's a tight methodology, and it's quite insistent on how you do things correctly. We used heat flux plates to do this. I'm going to put a link in the chat, or Richard or Tanya will send this link out to the full paper. It's freely available. You can just download it, and all the methods, the uncertainties and things like that, the important scientific bits are all in that paper. Next. So here's the important things to me. There's an absolute difference on the right hand, the second to the end right hand column, and there's a percentage difference. We can sometimes get lost in percentages, but they're quite good indicators, just while we haven't got the full time to kind of run through it. The ones with the lightning bolts next to them are the ones that are, let's say, the most interesting and furthest away from what we thought they should be if we looked at the assumed value in RDSAP. Okay, so, and there's some quite big numbers there, 41%, 46%, and 37%. 2 out of 3 are in sandstone, which is no surprise to me, but there's some solid brick properties here that were performing substantially better than we find in the assumed U-value model. A lot of this is down to wall thicknesses, how moist the wall is. There's many, many different reasons, but I think even just this small bit of research, 9 homes, adds something to the variance of what we measure against what we see in RDSAP and SAP. Okay, Richard, next one. So what does that look like in number terms? I'm not going to go as far as to say EPC bands and stuff, because Richard's already illustrated that. And there's quite a lot of stuff in the white paper and in my full report, my full conference paper. It's all in there. But go and bore yourselves to death with it. It's all in. the fact is, these are the heat loss figures through the walls. Okay, so these are how many watts per degree of temperature difference between inside and out is being dumped out of the wall, basically. So if we look at some of the measured values in orange against some of the design values that we see in blue, which are taken from SAP and RDSAP, then we see some quite big differences. And again, these lightning bolts kind of are pointing to those kind of three major ones. So without going into all the stats, there's quite a lot of big differences in those bar charts. Even if you didn't look at the numbers, you can see that they tend to be higher on design and lower on measure, and that tells us a nice story. Next. So let's just quickly stop and take a sense check, because what we mustn't do is like infer our entire national energy policy against 9 homes that I've looked at the National Trust. But I think Richard pointed out that there's a number of these studies that have been done, and they tend towards what we're saying here. They tend, particularly for the heritage stock, to underestimate the performance of a wall, i.e. they get it slightly worse in the energy models. The small sample, the uncertainty's all in the paper. Richard Jack loves an uncertainty figure, and it's all in the paper. So please do take a look at that as well. It's a single case study approach, but we still thought there was some interesting stuff that came out of it. Now, this session isn't about airtightness, but there is some useful airtightness stuff in that paper as well if you want to take a look at that. Okay, next. So the main findings are, clearly, measured U values differ significantly, and in all cases, they were lower than the assumed values for both stone and brick. So that's quite interesting. So when we compare them to the different models that we created in SAP and RDSAP, we were finding an 11% difference in the outcome of SAP compared to when we put the measured values in. I think the interesting thing for me is a lot of people in the world of historic buildings who I speak to on a quite regular basis are concerned about some minimum energy efficiency standards. I think that some of their worry might be put to one side if they can understand how their buildings actually worked compared to how we model them. Now, this isn't me saying that they deserve special treatment. It's me saying they've got special buildings, and if we measure them, we'll find out if they're better or they could be worse. And let's not forget that they could be worse than what the models are saying. So they might not need as much insulation or treatment, let's just put it that way, but they might need a lot more. And if the U value is worse than we thought, then the occupant side would benefit from having the right amount of insulation put in. So this isn't all about trying to make buildings appear better than what they are. This is about us saying what a building is actually like. And I think that's really important. So we need to think about policy, methods. We need to think about accreditation, which I presume Andy's going to, I know Andy's going to speak about in a sec. And we need to think about how we get it right. But I think from the evidence that we've seen over the years, that it's interesting to measure the actual performance of the building stock, even if it's a small number. I don't think we could do every single building, but it's interesting that we get it right for the important ones. I think that's it, Rich. I've got one. Yeah, just to say thanks to the National Trust, they funded the work and provide access to all the homes, and they've got very diverse housing stock, and this is really important for people like this who own heritage buildings to get it right. Thanks. That's it, Richard. Thank you.
Perfect. Thanks, Rich. I think it's really helpful. One of the advantages of a case study approach is that it contextualizes and allows you to imagine it a lot more, I think. So that's a really nice example. Right, Andy, I'll hand over to you next.
Brilliant. Thank you. I hope you can hear me, Rich. Yeah. It's excellent. Right. Hello, everyone. Thank you for having me today. Yeah, my bit's easy. I've not got the sexy, exciting bit with lots of graphs and facts and figures. I'm just going to tell you how it is from an accreditation perspective. We already can accept U values as inputs in our methodologies within RDSAP, SAP. HEM will have U value in it. SBEM has it in there as well. We talk about these things at retrofit because they utilize those methodologies. BS 40104 as a retrofit assessment process procedure will harness the use of U values. Here they are. This is a couple of screen grabs from our RDSAP platform. Nothing really interesting to see apart from the fact that it allows you to define a U value. You can use the default, and it will tell you what the default is based upon your data entry, driven by the H band and then the type of wall and whether it's insulated. And it pulls some of those table. I think it's S6 within RDSAP. It's been a while, but I think that's the right table. And obviously it varies by country as well. And for all the reasons that have been described, you know, those numbers are either bang on because they're averages, or they're out because you're looking at individual properties. And to a simple case of just being able to tick a box and then enter a U value in. The challenge that we have at the moment is that has to be done in line with conventions, and RDSAP, SAP, and SBEM utilize very similar sorts of conventions which dictate how you use that override. And I think, Rich, you're going to go into this anyway, so I won't wax lyrical on it, but we have identified that there is a very simple change we can make to those conventions to allow in-situ U value or U value measurement to be utilized in this space. And there are great parallels that we see when we look at things like air tightness testing. We have, since 2002, been doing air tightness tests on buildings from a voluntary point of view initially, all the way through to sort of 100% mandated. You must do them on every new build prior to the being signed off, and that value then gets entered into SAP, typically CAM in the future. And that's utilizing a competency scheme, and those figures are auditable and interrogatable and obviously transferable. So we already have a parallel which to point to, and we would like to try and apply that as quickly as possible within our national calculation methodologies. If you want to move on to the next slide, please, Richard. Thank you. What is it about competency schemes that we need then? Well, I mean, what we don't want is a Wild West which is out there allowing anybody to utilize anything they like whenever they like for whatever reason they like, and you know, there's a risk in any industry, in any walk of life, that if you allow that to happen, bad things will happen. Some people will do good things, and some people will do bad things. So we need to be able to oversee that sort of behavior and those sorts of outcomes. So whenever we create a competency scheme at Elmhurst, we have some sort of pillars that we put in place. We want to be able to have competent people come in, so we have to check that they're competent. We want to obviously manage and develop that competency over time, because that's the way things work. And then we want to make sure that when work is being produced, when something is being created, that it's done in the correct way, so we have a quality assurance process behind that. And of course we offer technical support as well, and a number of other things that are important, things like insurance, for example. We see a lot of people picking up new roles and new responsibilities and not really appreciating the insurance ramifications or implications of not being insured. So they're all important parts of what a competency scheme is. So that's what we create. So we have plenty of examples we can point to. Measured energy performance is another one, which is all about HTC. Is a very similar sort of thing. If you look at our air tightness scheme, again, the parallels are there as sort of previously described. If we move on to the next slide for us, please. As I say, this is a well-trodden path for Elmhurst, but it isn't really just about us, if we're being honest. This is about an industry that needs to do something better than it has been done before, and it's not right for one organization to do it and keep it all for themselves. It's not right for an industry to rely on a monopoly. We want to create something that demonstrates that it works, that then can go out and become a thing for the wider industry and be adopted by other schemes and other organizations. So that is what we're trying to do here. The key thing is we want those practitioners in there and the schemes to be independent, to have trust built into what they're doing. This is all about the truth. This is all about making sure that when somebody makes a decision on a property, they've got the right information, and that is the truth of what is going on at the property. So yeah, we want that to be out there, demonstratable, accepted, and then replicated across the industry. Next slide, please. Measurement in practice, and I mean, there's much more to say that's on the slide really here. We're looking to create a model that isn't expensive, that is repeatable and isn't going to cost a huge amount of money. It's obviously got to cost something. You've got to do the job properly. You've got to get someone to site. All these things are unavoidable, but we want to create this model that works on a cost-effective level, and we want to have that comparable to airtightness, because again, the parallels are there. You need kit, you need people, you need competence, you need to do a job, you need to be on site for a period of time. Airtightness is a perfect model that we can point to. We've already got ISO standard, parts 1 and 2 of 9869. I'll get that right one day. Does already exist, and obviously these things evolve over time as things move forward. That's not a done deal. It's always being reviewed. That's the principle behind these standards. So we've already got the model, we've already got the process, we've already got in mind what we want to achieve, and we've already got a standard to work to. So if you move on to the next slide, please. And we're already future-proofed, really, as long as we can build it, and as long as in some cases the government is going to need to say yes to things. I think in other ways, particularly around the retrofit piece, we've got a slightly different ownership model over there and a different level of risk, a different requirement, but we just need to get this to a point where there is acceptance the model works and is repeatable and is good, but the framework is future-proofed. We're not creating this for RDSAP only or SAP only. We've got future home standard and the home energy model in mind, and that's that's coming this year. We also mentioned the other things like BS 4104 and retrofit in general. So we want to make sure that when we release this, we're not having to then change it again the next time something seismic happens in the industry. We're also mindful, as we say, MEES is sort of like one of those things that's come out into the industry 5 or 6 years ago, and whether we realized it or not had a big impact, and it's a huge responsibility, but it's also problematic, as Richard Fitton says, for certain types of buildings. So again, we want to make sure that this model is in place in time for the sort of the big upswing in things like MEES and others. Warm Homes Plan is another great opportunity to have this there and make sure we're actually getting good value for all the funding that's there, that is being spent wisely, it's been spent on the right buildings in the right way. And in that, we've got trailblazer combined local authorities that are looking at how to utilize this. So I've spoken to a few of them now, and there's 2 trailblazers at the moment. There's Manchester and West Midlands, and obviously there's the GLA as well. But then there are probably 6 or 7 others that are going to join them in the next year. And they're all kind of looking at each other. They're looking at the trailblazers and saying, well, what are you doing? What works for you? And I know that measured energy performance as a principle, and I throw in CTU value into that, along with air testing and HTC, etc., that they're all being utilized or will be utilized in some way, shape or form within those combined authorities for their retrofit funding programs, some of which will utilize Warm Homes Plan. So that's why this matters. We want to make sure that when those things get into full swing, MEES, Warm Homes Plan, others, we are ready and we are able to utilize this excellent method, these excellent technologies to do good things with them. And I think that's me. Chris Ricketts has given me a thumbs up as well, so I must have done a good job there. Thank you.
Thanks, Andy. Yeah, really good to put it into context. And also, thanks very much for mentioning non-domestic buildings and SBEM, because I often tend to forget just because of what I've been interested and worked on mostly in my career. So I just want a few slides to finish up with what we think change looks like. So here's a long slide of the current convention and our suggestion of what the change would be. So you can see the red text is the new text. This is for RDSAP, and what we're basically saying is that we believe that in addition to using the lookup table and a calculation, you should be able to use a measurement if you follow the ISO standard and if you're a competent person. So we imagine that it would have the same apparatus that Andy's just described, that airtightness currently does as an example. I think that's a good thing to use as an exemplar to imagine what it might look like. Is it really as simple as that? Yes. So what changes do we need? So for the apparatus around an EPC, it's literally the conventions need to change. We need to decide corporately that it's a good idea and change the conventions. The measurement tools are already in place, which we've already heard, and the scheme is already in place. And as Andy highlighted, it's an exemplar. It doesn't need to be an Elmhurst scheme. It's there for others to adopt, should they be interested in. So that's it. I've got a few dates for the diary just to catch up on, and then we're going to open up for questions and answers. So if you're hearing this and thinking, I really want to learn a lot more about U-value measurement, there's a couple of training dates here that I'll be delivering. So if you want to hear more of me, then A, you're mad, and B, here's some dates to do so. And then dates for the diary, Elmhurst National Conference is coming up very soon. It's both got good content and excellent food, so highly recommended by me. And our next webinar will be on the 5th of March, which is about embedding building performance measurement in public sector projects through procurement. So it's a bit of a dry topic, but I really think that is totally vital for adoption. So it's one for the diary also. So thank you very much to Andy and Rich, and now let's have lots of good questions and debate.
Thank you ever so much to all of our speakers. We've had lots of questions in, so I'm going to start right at the top. So obviously these are in chronological order, so those of you that spoke earlier, you're going to have to rack your brains a bit. There might be a bit of backwards and forwards on the slides, but I'm sure we'll work it out. So the first question that came in was from George. He's asked, is it an accuracy question or a poor construction workmanship question? What is the causation of these disparities?
Well, I don't want to be a big mouth, but I'll start off answering one. So I think it's really varied. I honestly think that I remember when I went for a PhD interview, my future supervisor said, "What is insulation?" And I said, and what he was saying was, insulation is a way of trapping air. And if you've got any air movement where that insulation should be, then you're going to have a problem with your U value. And that doesn't mean air permeability, that means air penetration through the insulation. So I think that is the #1 cause of discrepancies. And it depends a lot on what you're talking about, right? So if it was this building, it was built as an ammunition depot a couple of 100 years ago. You're not going to go to the builder and bring up their build quality because you can't talk to a cadaver. But if it's a new build, then you're in a different conversation. So yeah, that's what I'd say.
Brilliant, thank you. And then George did actually follow that rapidly with a follow-up question. Do measured U values tend to shift seasonally? How is this accounted for?
Nominate Rich.
Yes. Yes, they do. The same with anything that can get moist or can be affected by wind or solar radiation or anything else will change over the season. Rich, it did occur to me, and this might wipe a load of the questions out in one foul sweep. We've not really talked about how we measure a U value. So why don't I spend like one minute and just like say how we do it? So, and for those who already do this, apologies. In essence, and I'm simplifying, we go to a building. We only do this during the heating season. Okay, so we don't do anything tend not to do anything outside of the heating season. We've got two methods of doing it in principle. We have an infrared method that uses a platform that Richard will talk about probably towards the end. And that captures infrared images on a regular basis and does it like that. I think the more common way that we've done it over many years for is we stick sensors on a wall. They're usually disc shaped, like red discs and blue discs that we stick onto a wall, and we usually stick 3. So some slightly near the top, one in the middle, some slightly near the bottom. And this is a typical scenario. And then we measure the temperature inside, we measure the temperature outside. These 3 discs, they measure the amount of heat that's going through the disc. And that tells how much heat is going through the wall, ultimately. And it measures it in watts per meter squared. And the really basic principle of this is that you just calculate how many watts is going through, what the difference in temperature is, and that basically, with some sense checks, some averaging, and some small amount of data analytics, but also a lot of sense and judgment, that gives us our U value. We tend to do it for at least a minimum of 3 days, because that's what the international standard says, but often longer, maybe 4 days or 5 days. It really depends on the weather, the internal temperature, and things like this, and also the wall, how thick it is, how resistant it is, and things like that. So really, that's what we do. We stick some sensors on a wall, we measure temperature inside and outside, we record it to a data logger, we come back in about 5 days' time, we take the data off, analyze it, and we can spit out a U value from that. The equipment is fairly expensive, it's safe to say, but it's coming down a lot in price, and a lot of people are working on different solutions to do that and to also automate this process as well. So I guess it's like Richard and Andy said earlier, it's all quite similar to air tightness. You've got to do an upfront investment, you've got to do some training, you've got to do some probably accreditation through a scheme, and we have to have confidence in the results that we're generating, and that's kind of it. That's the principle. But I thought we might have missed that out a little bit, chaps. So yeah.
And I think one implication, coming back to the original question, is about the precision with which you can measure anything, but in U values in this case. So what we'd be talking about is really like tenths of a U value. So here's a U value 0.1 or 0.2, rather than is a U value 0.11 or 0.12. So you're really at tenths of a U value, and the variation in performance seasonally is really within that zone. Your U value is not going to change from 1.1 to 1.5 over the course of a winter, but it could change from 0.11 to 0.13. So we're really talking in the levels of tenths of a U value.
If they're changing heavily, then there's something probably wrong with the fabric of the wall, i.e. it's becoming saturated from a leaking gutter or something like that, which is actually still quite a good use for U value measurement.
Great. Okay, so we will carry on rattling through this ever-increasing list of questions. Is it possible for a resident to gather measurements through simple sensors to determine their effective U values?
In a rudimentary way, yes. There's really basic measurements you can take with surface temperature, which would allow you to do a semi kind of constructive version of it. But we would never accept that as an accredited test. Definitely not.
I'm going to add a question to that, actually. I'm just thinking about how you triage sort of this concept, because I sort of accept that people want to utilize it at the right time. If somebody is sat in their home and they've got the heating on all the time and they're still cold, and all intents and purposes they should be warm, is that the sign? Should I get some analytical tests done to understand my property?
I think if so, I always talk about energy pathology. If you, and same as building pathology, if you think there's something going wrong with the building, then pathology is the only way to look at it, and that might be measuring air tightness, it might be thermal cameras, it might be measuring the U values. I don't think you're ever going to get one answer, one thing that gives you all the answers, and that's what a good kind of assessor, surveyor, building physicist, whatever you want to call us as a kind of a group of people on this call do. It's about having the right tools. A plumber wouldn't go to a job with just a spanner. He might have wrenches and screwdrivers and this and the other. It's about having the right tools for the job.
Not met my plumber.
Thank you. Okay, next one. Has there been any work done on the performance of wimpy no fines properties?
Yeah,
I've measured a few actually myself. I don't think, when I did measure, I looked for a source, a report which had several measurements of wimpy no fines and didn't find it. So when I measured a single wimpy node finds, the U value was actually really much better than expected, about 0.9. But that's definitely in the case study level at one building.
So I think Rich, Leeds Beckett might have done some work with the Northern Ireland Housing Executive. So if you Google that, you might find some from experience. Both are working in them and measuring them. They're wildly varying because the concrete mixes were so variant. It's the same as a stone wall. You don't know what's inside it until you start to take a deeper look. Simpler. Someone's just put simpler, and that's right. Yeah. Now it all comes flooding back.
I read that, and it said that the performance of them built on a Friday was noticeably worse than the ones built earlier in the week. So they're trying to get up quicker and put more coarse stuff in the mix.
Surely not. Surely not.
Okay, we'll leave that there. Is there scope for ISO 9869 Part 2 results, Heat 3D, to be accepted as credible evidence in RDSAP?
Yeah, I would say so. Providing that we credit everything, and it's an internationally recognised standard. So I see no reason why not.
Agreed.
And how does this compare to SMETA?
SMETA is a measurement of the overall level of heat loss for the whole building. So it would be a sum of the U value of every surface, wall, floor, ceiling, windows, plus air movement due to infiltration and ventilation. And a U value measurement is the performance of just one element, so a bit of the building.
Why not do both? Would be my response. You can find out a building, and me and Richard Jack spent years probably discussing this. You can find out the heat loss of a building, like Richard said, all those aggregated things, but you don't know what the bad thing is. So how do you fix it? How do you improve it? The elemental and aggregate is probably the way. You go to the doctors, he'll look at you, but what you really need is to go to see a specialist. So yeah.
This comes back to your tools, isn't it? You've got to have the right tool for the job.
Yeah, absolutely. So as you've shown, the measured U value varies from the RDSAP assumptions, but how does it compare to calculating the U value BR443?
I mean, I'll have a go at answering some of this question. We're never quite sure how the RDSAP and SAP, RDSAP assumed U values have been calculated, because I don't think I've ever seen them. What's gone into them? They are averages of averages ultimately. So in calculating, you are putting in exactly what it has been specified within that element, whether it's a wall, floor, or roof. So you should be getting a more accurate answer, but again, we don't know all the other things that go along with those individual elements. And actually, has anything changed since that specification was put together? Has it been built to that specification, and has anything sort of changed, moved around, been altered, disrupted since that point? That's part of the answer, I think.
I think there's also a halfway house. There's a halfway house, and I've had to do this, and I did it on not one of those properties, but another National Trust property. They wanted some detailed U values for the walls, but it was summer, and they wanted them straight away. So we drilled it, and we found out exactly how thick the brick was, what type of brick it was, exactly how wide the cavity was, and exactly how wide because when you're working in heritage, you don't ever really know what's inside them. And we boroscoped it and measured it and this, that, and the other. And then we calculated the U value, and it was different than the U value that would have been assumed by John, the DEA, that went and rightly picked, because they should, the assumed U value. So yeah, there's a halfway between that.
Mm-hmm. In the slides I presented, I showed the level of variation of a set of new build walls and floors. So they are calculated U values, and the level of variation was well over 100%. So absolutely demonstrable that the calculation isn't accurate for every building.
I don't think it can be accurate for every building. Like Richard's graph shows, it's an average, and all averages are wrong at some point. So yeah, it's the best we've got.
Okay, and we've also had a kind of an observation that's also a question. Suppose that the problem could also be a landlord can choose either the default or measured U value to comply with NEES.
Yeah.
I think that's a scheme question, Andy.
Yeah. I mean, again, whenever you're utilizing, I think there've been a couple of questions that sort of alluded to this. If you're going to utilize a calculated U value, then you need to back that up with evidence, and it needs to be done by a suitably competent person, and that's detailed in the conventions. And anybody looking at that needs to assess whether that person's competent, so they need to see their credentials and what have you, and the U value calculation should have that in there as well. Whereas if you're using the default, obviously you're just using the table. Both are legitimate as long as you've got the evidence to back them up.
Yeah, and let's not forget the fact that I think what we're playing and talking about here is people trying to game the system.
Yeah.
It's human nature. People will try and game any system, and it's up to, people like Andrew to kind of sort that out. But you can game it just by changing the wall thickness or the wall type, or you can just literally just pick a different thing on SAP if you want to game it. That there's no way of stopping that other than auditing and quality assurance. So yeah, it's open to abuse no matter what, really.
Yeah, and as I said in my presentation, one of the reasons why schemes exist, as another check and balance in that process. But you're right, it's human nature, isn't it? When you put a line in the sand, and if you're over the line, you're good, and if you're under the line, you're bad. There's a lot of stuff happening around that line.
I'd just like to add something to that, which is that conversations we have with government, that obviously if you're choosing a default, and at some point, if we have an agreed scheme and processes, and somebody decides to do a measurement, and that measurement turns out to be worse, then that's what they have to put in. That prevents the gaming. Sometimes these things will be beneficial, but they don't always turn out to be beneficial, and that comes with the territory.
Absolutely, Chris. Yeah, and of course, if you're going to use something at the start, a measurement at the start, or a calculation at the start, you have to use the same
methodology.
Otherwise, you're creating a disparity, aren't you?
Yeah.
Absolutely. Okay, so the next question I'm going to point to Richard Jack. Where do you get accreditation for measured U value measurement?
Yeah, good question. I mean, at the moment you don't, because it's not a permissible input, but what we're suggesting here, the structure is that you be trained on how to use the equipment, and we offer that training, and then you would be a member of a competent person scheme, and Elmhurst scheme is an example of that. But there's a clear route.
There is a lot of paralysis from analysis. Is it not as simple as the world accepting that uninsulated buildings are poor?
Yeah, but some are less poor than others. We need to know how poor they are. And the reason we need to know how poor they are is so we can get them to be correct. And no one wants to misunderstand buildings, particularly older ones, where we might be doing something that's counterproductive, like over-insulating them, for instance. So, yeah, listen, no, I don't like analysis either. And sometimes we have to just kind of use common sense. But the idea is that we make systems like this simple, and as simple as just sticking sensors on, doing some training and helping people with technology, that you don't have to kind of just overanalyze everything as well. It's as obvious to me as anything really that it can be over complicated.
Yeah.
Absolutely.
One thing we didn't cover. Sorry to jump in again, Tanya. One thing we didn't cover, and I think is a reasonable thing to say, although there's always nuance in this. But the more of this we do, the more we understand our buildings and the things that make them unique and that make them the same, we can start to alter some of our assumptive positions. I'm not saying we can get to the absolute truth using an assumption. That's not possible. But I think some of these U values are probably wider than mark to a point where we ought to be changing them. So I think there's something there for us to look at. I'm always a big fan of a process feeding back in on itself and improving.
Yeah, one big benefit of this that we didn't mention is that by bringing this in, we'd learn a lot about buildings, so we would find out which things work and which things don't. The other side of that question would be, can we assume that insulated buildings have good performance, and the results say absolutely not? We can't rely on that.
Yeah, absolutely. We've also had a couple of questions that overlap, so I'm going to kind of bring it all together as one. And again, I am going to go to Richard Jack for this. What are the kind of the differences now? Because there's the two measurement systems with the adding the probes onto the walls that need to be left in place for days, and then there's Heat 3D with the thermography. I wonder if it's worth just quickly describing the main differences as to how Heat 3D does that a bit quicker and a bit differently, and then as part of that is what would be the likely date where the infrared thermography could be included into RDSAP or SAP?
So the difference between the two is that a heat flux plate is a reasonably small sensor, so you measure a relatively small area, whereas the infrared imaging, you can take images of large surfaces, so you can average over a larger area. So a benefit of infrared is that you can measure over a larger area. A benefit of using a process like Heat 3D is that it's shorter, so you can do a measurement in around an hour, and it could be part of your normal survey process. A benefit of a heat flux plate is you can measure with slightly more precision. So if you really were interested in, is my U value 0.23 or 0.29, then a heat flux plate would probably be a better tool to look at if you're trying to get at less than a tenth of a U value level of precision. They're both defined under this ISO standard, so they're of a similar level of maturity and documentation, so there'd be no difference in date, in our opinion, of when they'd be permissible under RDSAP. They'd come in together.
Thank you for that. And one final question that we have had come in is, Dalton Dab plasterboard homes suffer from air wash behind the plaster. This greatly changes the U value depending on the wind, with little effect on air tightness. Any comments?
I can maybe talk to that. I forgot something in my introduction to U values. When we place sensors, we tend to use a thermal imaging camera if we've got one, to help us take representative parts of the wall. Now, if there were dabs all over this wall, then we might want to take a reading on one of those dabs to kind of get an idea of the good and the bad parts of the wall, maybe do some kind of weighted analysis. Go into a bit of detail there, but the fact is that we need to pick somewhere on the wall that's representative. There might be a really super bad part of that wall, and we don't want to stick the sensor just on that, or equally just on a super good bit. So yeah, I forgot about that. And clearly, when we're using the infrared systems, that wall, if you like, is mapped. So we can choose sensible things to kind of look at there as well. So yeah, it's a fair point. It happens a lot, and we see for people who don't do a lot of this measurement, and I'm hoping Richard Jack's going to agree. When we don't do the training and we put like things in the wrong place, we get bad measurements, that bad in, bad out. It's as simple as that. Someone just popped up a thing there. Can we put more than 3 plates? You can put as many as you want on, but they're bloody expensive. So yes, the more the merrier. But obviously, we generally see 3 as a kind of a good starting point.
And one final question has sneaked in. How do you add the effect of thermal break materials in the U value calculation?
Well, I mean, I guess that, if it was to be cheeky, I'd say that's a question for a U value calculation webinar rather than a U value measurement webinar. And actually, it is a bit of a complicated thing for U value calculations, in the same way that a U value measurement, you're looking at which bit do I measure, where the dab is, for example, or where there are things in the wall or not. It's the same in the calculation. How do I accurately represent the average performance over the surface rather than particular areas?
Thank you for joining us for today's webinar. If you have any questions or require further information, please do not hesitate to get in touch, and we will see you at the next one.